Okay, blood. So what we're going to be doing here on the series of blood lectures that we're going to do, I think there are going to be like 3 of them, 3 or 4 at most, is we're going to talk about the components of blood, basically red blood cells, white blood cells, and platelets, and their function, how they're formed, how you make a clot. We've already talked about the ABO blood groups and the RH blood groups in lab when we did the clotting experiment or demonstration. I'm going to talk about how the shape of a red blood cell, which is the structure of erythrocytes, and how they function in the transport of oxygen and carbon dioxide. So basically what we're going to do is we're going to be talking about hemoglobin. And then we're going to talk about erythropoiesis, basically how blood is formed and the hormones for it. All right, so what are the functions of blood? So you know how I like to start out. So what are the functions? So basically, blood functions to transport dissolved elements. Or materials. Okay. Of those, we have oxygen and carbon dioxide. Okay. We have our nutrients. So basically, this is our glucose, lipids, amino acids, vitamins, etc. Okay. Pretty simple stuff. Okay. It is there to transport immune system components. And basically these are immunoglobulins. It is there to transport waste products. Okay. Blood is also important in the regulation of pH, because you know normal pH is 7.35 to 7.45. Blood helps with that in the form of what's called bicarbonate. Okay, and the stabilization of body temperature, which I talked about when we in the skin lecture. Okay, so those are the functions in a nutshell. Right. So next, we have the components. What is blood actually made of? Okay, so you cut yourself, you look at blood, and you're like, oh, it's this red fluid. Okay, so it's got basically 2 parts. Okay, the first part is the plasma. Okay, and this is the liquid part. It is about 50 to 60% of blood volume. Okay, 56%. Okay, of this 50 to 60%, 90% of that is water. Okay, so your body, your blood is mostly water. Okay, the remaining 10% of that 50 to 60% are proteins. The one I want you to remember forever is albumin. Okay, albumin, I'll underline it, put a little star next to it. Okay, then you have these smaller proteins called globulins. So I mean smaller, that they're smaller than albumin. Okay, and then fibrinogen. Okay, so those are our big important ones. Okay, so these guys here, they're created by the liver. 90% of them. Okay. And then what else we have in the plasma is we have our solutes. Okay. And the important ones I want you to remember forever for the rest of your lives are sodium, potassium, and chloride. Okay. Sodium, potassium, and chloride. Sodium and potassium more than the others because sodium and potassium drive a lot of what's going to happen in our body. Okay, so that's the first part. The second part of the blood are the formed elements. Okay, so our formed elements, and these are simply the erythrocytes, and these are the RBCs, the red blood cells. Then you have the leukocytes, and these are the WBCs, your white blood cells. And then you have your thrombocytes. And those are your platelets. Okay, so those are the formed elements. And if you divide that out, that gives you everything that your blood is. So if we wanted to make a little diagram, we can do it like this. We can do this. We can have a little box here. We can have a little box here. Okay. We can say here plasma. Okay. And then we have like little proteins. 7% run there. Other solutes, we'll just call that 1%. Okay, and then the rest of this here, this is all water. That's what 90% ish. They're not exact, doesn't have to be exact. Okay. So 55% plasma. And then the other part are formed elements. Okay. And so that's about 45-ish%. 45-ish. And of that, we have platelets, which is less than 0.1%. Okay. Very little amount. Then you have WBCs. WBCs are leukocytes, less than 0.1%. So there are very few leukocytes in the blood. And then we have the big one of all, RBCs. 99%. Actually 99.9% or 8% if you want to get really technical. Actually, no. We're just going to say approximately 99.9%. Okay. So of the formed elements, your red blood cells make the majority of what we're dealing with. Okay. So moving on, let's talk about blood characteristics. Okay. So what is the blood like? Okay, so the temperature. Average temperature of blood is 38 degrees Celsius, which is approximately 100.4 degrees Fahrenheit. It's about 1 degree warmer than surface temperature. So when you take your tongue, you take temperature in your tongue, you just add 1, that's internal volume. Okay. Blood also has a high viscosity. And viscosity is nothing more than just a measure of how thick something is. Blood is thicker than water, so it's got a higher viscosity. Okay. Blood is alkaline. Okay. This is just a fancy way of saying basic. Okay. Remember, it's got a 7.35 to 7.45 pH. So it is higher. Remember, anything that is lower than 7 is acidic. Anything that is higher than 7 is basic. So remember, 7 is neutral. 7 is neutral. When you have something that's neutral, there's as much hydrogen as there is hydroxide, or they're balanced out. The blood is barely basic, barely. Okay. Now, how much blood do we have, characteristic-wise? In males, okay, there's approximately 5 to 6 liters of blood. Okay. In females, okay, it is 4 to 5 liters. Okay. So if you want to put this out, how can you relate to 5 to 6 liters of blood. So basically you have about males have about 2 liters of Pepsi. So if you look at how much Pepsi or Coke would be in a 2 liter, multiply that by 3, you get about how much blood there is in a male. A little bit less. And then the female, about 2.5. 2 liters of Coke. So pour that. So, if you want to be weird, you can get some 2 liters and just dump them out into a bucket, and you'll see how much blood that actually is. So some people say it's a lot, but 2 liters is not that much. It's really not that much blood. So that's it. Those are the characteristics that you should know about. And finally, how are they formed? Okay, so basically what I want you to remember about erythropoiesis is one, what the word means. Okay, it means the creation of blood cells. Okay, it's the process of forming new formed elements, and that's a weirdly weird way to say that. It is the process of forming new blood cells. Okay, that's all you need to know about that. Okay, you need to know, where does it occur? It occurs in the bone marrow. Okay, of the adult. Okay. Actually, not of the adult, but of the post-adolescent onwards. Yeah, because it changes spots. It really does. When you're goo in your mama's belly, it's actually in the yolk sac, and then it moves to the liver. Okay, and then finally, it then moves to the bone marrow itself. So it bounces around a little bit. Okay, so now of bone marrow, we have 2 types of marrow. And the only one that actually will produce blood cells is the red bone marrow. Actually. Okay. Now, all of your bones have marrow in them, okay, but not all of them will produce blood cells. When you get to be an old fogey like me, pretty much you got the sternum, your breastbone, and then the pelvis. That's where it is. So you youngins out there, your femurs are probably still producing some blood cells, probably your tibias and your humerus as well. But as you get older, it starts to isolate itself down to the pelvis and the sternum itself. Okay, so that's red bone marrow, produces our blood cells. And then we have this other kind of marrow. It's called yellow marrow. I'm just doing it for completion. And basically, it has just got a lot of fat. There's a lot of fat and the yellow marrow. Okay. Now the thing about this is yellow marrow can turn into red marrow if need be. But all I need to know is that red bone marrow is responsible for production of our formed elements. Okay. And then the last thing about erythropoiesis is every single blood cell, every red blood cell, every white blood cell, and every platelet comes from a single cell. Okay, and it is called a hemocytoblast. Yes, it's a big word, but hemocytoblast. Okay, so you're all in med term, so we can dissect that word. A blast cell is not an old cell. It's not an immature cell like a lot of the midterm book says. This is a cell that creates. Okay, that's what a blast is. It's a cell that creates. Cyto is cell. Hemo is blood. Okay, so the hemocytoblast is a cell that creates blood cells. Okay. That's all a hemocytoblast is. Okay, so from this hemocytoblast, it is resident in the red bone marrow. So it resides in red bone marrow. And what this is a stem cell. It's a stem cell. So what this stem cell does, this is our hemocytoblast right here. It will sit there and it will just hang out. So I'll call this hemocytoblast. Okay? And it'll hang out. And at any given time, your body might need some red blood cells, it might need some platelets, or it might need some white blood cells. So basically a hormone is going to come along. Okay. If you need red blood cells, you're going to get this hormone called erythropoietin from the kidney. And it's going to come and it's going to stimulate this hemocytoblast. Okay. And this hemocytoblast, there are two possible pathways that it can divide down. Okay. It can divide down this one called the myeloid path, or you can go down the lymphoid path. Okay. But we want to have a red blood cell. So what we're going to do is we're going to go down the myeloid path, and you don't have to know all of the little things. If you look in your textbook, they're probably going to give you this diagram that's got like 15 different arrows, and that's going to show you like every cell that it could come from. Don't need to know all that. Okay. You need to know that the hemocytoblast can go two ways. It can go myeloid or it can go lymphoid. Okay. Now, if it's going to go, if it goes down the myeloid path, it can make red blood cells, or it can make platelets, or it can make some white blood cells, or some WBCs. Okay, and the white cells that it can make, they're called basophils, okay, eosinophils, okay, or neutrophils, and one of my favorites, the monocyte. Actually, no. The neutrophil is probably my favorite. Okay, so those are the cells that we can get on the myeloid stem cell. I mean, this myeloid stem line. Okay, and so if we want erythropoietin, what that's going to do? So if the cell gets bombarded with erythropoietin, it's going to tell that cell to go on the myeloid line and become a red blood cell. And there are other things that will tell it to go toward a platelet or one of the several white blood cells that it can make. All right, now if we get another hormone called leukopoietin, okay, if leukopoietin does it, it's going to make it go on the lymph line. Okay, so I'll do that. So erythropoietin is also going to make this go on the myeloid line. Okay, leukopoietin is going to make it go on the lymphoid path. Okay, and what that's going to do is it's going to make lymphocytes. Okay, and these, you know, are T cells and your B cells, which will turn into plasma cells. Okay, so that's it. That's our general overview of blood cells, and that's all I have for this one. There'll be more coming soon.